Good morning, everyone. My name is Saransh, mm, good morning, everyone. My name is Saransh, and I'm a lecturer in Suraj Gyan University. And today we will discuss about heat transfer performance. It must be pointed out that the Kulwani engineer L studied and founded that the turbulent flow pattern gas in a gas liquid interface, heat transfer coefficient, and the immerse to surface has a significant impact. Under Kulwani engineering inspiration and guidance, our work is mainly describe the flow pattern characteristics of bubble under the effect of heat transfer in the DCHE, which is the full form of direct contact heat exchanger. Dehika ETL and the Thayer ETL used to the Betti numbers to represent the heterogeneous and pseudo homogeneous of the bubbles. In addition, the relationship between the Betti numbers and the heat transfer coefficient has been obtained in DCHE. Some factors like mixing time, L to star discrepancy, and the last is modified L to star discrepancy. First of all, we will discuss about mixing time. Both mixing speed and phase transition time in the direct contact volume heat transfer process are fast, and accurate mixing time is critical to appropriately evaluate computational fluid dynamics models and then enhances equipment understand and develop scaled down model for process characterizations and design specifications during the last stage process development. In the past few years, many researchers have studied the mixing time and many methods were proposed to measure mixing time. The mixing process in DCG has been studied by many experiments. Similarly, at present, there is no generally accepted way to measure ho- mixing homogeneity, mainly because each method has its own uh, differences, such as with thermal method, conduct metering method, DC method, decolorizations method, Cilian method, Pettinberg method, etc. I will start discrepancy. Recently, we were utilized and motivated by the XU it L by the literature that introduces the relatively not complicated and accurately uniformly coefficient technology, which is based on image processing technology and the theory of uniform design to determine the mixing time and uniformly in DCHE, which is full form of direct contact heat exchanger. The space time characteristics can be quantified by means of the uniformly coefficient method, which based on the L to star discrepancy and provides some method of direct measurement about the macro mixing evaluation. We will discuss about boiling. Boiling is the process of turning a liquid at its saturation temperature into vapor by applying heat. In both cases, there is a liquid in contact with the surface and the transfer is good. When the temperature of heated surface is very high, the characteristics of the boiling process change. Different regimes of boiling heat transfer. and the boiling phenomenon corresponds to the boiling or post boiling. There are three different types of boiling associated with progressively increasing heat flux. Design identified in figure 12.8, which shows the relationship between heat flux or boiling quotient and the temperature axis at Ts minus T saturated. Ts is the temperature of hot surface and T saturated is the saturation temperature corresponds to the pressure at which the liquid is being evaporated. And uh, boiling phenomenon corresponds to the full boiling process. There are three different regimes of boiling associated with the progressively increasing heat flux. These regimes have been identified in figure 12.8, which shows the relationship between the heat flux and the temperature axis. Ts is the temperature of the hot surface, and T saturated is the saturation temperature corresponds to the pressure at which the liquid is being evaporated. बॉलिंग का होता है कुछ बार बताया है कि जैसा कि हमने यहाँ पर डिस्कस किया था कि बॉलिंग एक प्रोसेस जिसके अंदर मतलब कि किसी भी लिक्विड को जो है चाहे वो सेपरेट करता है और उसको लिक्विड फॉर्म लिक्विड फॉर्म के अंदर ट्रांसफर करता है ठीक है और इन दोनों के अंदर मतलब कि क्या लिक्विड जो लिक्विड का सल्फेट कंसिडर करेंगे जो कि इस लिक्विड के अंदर काम करें और इसमें बोल रहा हूँ इस टेस्ट के साथ में या ट्रांसफर के साथ में कॉन्टैक्ट में आता है, तो वो एक अच्छी ऑफ द हीटेड सरफेस इज वेरी हाई और जब किसी भी जब हीटेड सरफेस का टेम्परेचर जब बहुत हाई होता है तो जो कैरेक्टरिस्टिक्स ऑफ द बॉइलिंग प्रोसेस जो है वो हमारी चेंज होता है ठीक है यहाँ पर लिखा है कि व्हेन द टेम्परेचर ऑफ द हीटेड सरफेस इज वेरी हाई मतलब कि कोई भी लाइक कि ये एक मेरी हीटेड सरफेस है ठीक है और इस हीटेड सरफेस का टेम्परेचर अगर मैं हाई कर देता हूँ लाइक पहले इसका मतलब टेम्परेचर अगर 100 डिग्री सेंटीग्रेड था और मैं उसको 100 से 250 300 या 500 डिग्री सेंटीग्रेड कर देता हूँ तो क्या होगा कि इसका जो बॉइलिंग प्रोसेस जो है वो हमारा चेंज हो जाएगा ठीक है और इस बॉइलिंग प्रोसेस को जो है या इस बॉइलिंग हीट ट्रांसफर को जो है तो इसका हमने combo किया different there are three different regimes of boiling associated with progressively increasing heat flux. These regimes have been identified in Figure 12.8, which shows the relationship between heat flux and the temperature axis. Ts minus T saturated, the temperature of the hot surface, and T saturated is the saturation temperature, corresponds to the pressure at which the liquid is being evaporated. Next is a rise in the slope of the curve indicates an increasing heat flux with increasing temperature. This and the boiling regime seems stable. When the slope decreases, the boiling regime is unstable and not be avoided. These different regimes can be illustrated by considering an electrically heated horizontal wire submerged in a pool at saturation temperature. The heat flux is easily controlled by voltage drop across a wire of fixed length. ठीक है। तो हम यहाँ पर बात कर रहे थे डिफरेंट डिजाइन ऑफ बॉलिंग हीट ट्रांसफर। ठीक है कि इसके अंदर हमने बात करते हैं कि सर वेदर द बॉलिंग फेनोमेनन corresponds to the pool boiling or forced circulation boiling. There are three different regimes of boiling associated with progressively increasing heat flux. These regimes have been identified in Figure 1200, which shows the relationship between heat flux or fuel coefficient and the temperature excess. Ts minus T saturated. Ts is the temperature of the earth's surface, and T saturated is the saturation temperature corresponding to the pressure at which the liquid is being evaporated. Rise in the slope of the curve indicates an increasing heat flux with increasing temperature excess, and the boiling regime is stable. When the slope decreases, the boiling regime is unstable and must be avoided. These different regimes can be illustrated by considering an electrically heated horizontal wire submerged in a pool of liquid at saturation temperature. The heat flux is easily controlled by voltage drop across a wire of the fixed resistance. Evaporation process with no bubble formation, like interface evaporation. Next is nucleate boiling, and next is film boiling. First of all, we will discuss about evaporation process with no bubble formation. The boiling takes place in a thin layer of a liquid which adjoins the heated surface. The liquid in the immediate vicinity of the bowl becomes superheated. Temperature of the liquid exceeds the saturation temperature at the given pressure. The superheated liquid passes through the liquid vapor interface where evaporation takes place. The fluid motion is determined primarily by the free convection effects. The heat transfer rate increases but gradually with growth in a temperature excess. Temperature excess T saturated minus Ts minus T saturated figure 12.8 boiling curve for water. Surface heat flux as a function of excess temperature. Here, we will discuss about this diagram, which which is drawn between a log EH and the temperature axis. Temperature axis like Ts minus T sat means T saturated, which is calculated in degree centigrade, and log EH, which is a height, and it's calculated in a watt per meter square in degree. Uh, and and it's so converted into three parts like interface evaporation, next is bubbles, and next is well, first of all, we'll discuss about interface evaporation. We will discuss about pure convection. Pure convection heat transferred by the superheated liquid rising to the liquid vapor interface where evaporation takes place. Next is bubbles, which is uh, which is identified into two parts like nucleate boiling, uh, in which we will discuss about bubbles. Uh, Condense in a superheated liquid, etc. As in a case. And the next is spherical state beginning, nucleate boiling bubbles rush to interface. And the next is stable film boiling, radiation coming into the play, uh, which is coming on three region, which is called film, and temperature excess like 0.1 degrees centigrade, 1.0 degrees centigrade, 10 degrees centigrade, 100 degrees centigrade, 1000 degrees centigrade, and 10,000 degrees centigrade. Now we will discuss about liquid boiling. When the liquid is overheated in relation to the saturation temperature, vapor bubbles are formed at a certain variable spots called the nucleation or active sites. These may be the wall surface irregularities, air bubbles, and liquid bubbles. The bubbles grow to certain size influenced by the pressure, temperature, and surface tension at the liquid vapor pressure. Now we will discuss about it depending on the temperature axis. Depending on the temperature axis, the nucleate boiling essentially consists of the following stages. First, bubbles form and collapse on the surface itself. Next is bubbles form and the heated surface but get condensed and the liquid after detaching from the surface. The next is bubbles form and break away from the heated surface with increasing frequency and intensity. The liquid is, however, too hot and the bubbles do not condense. Instead, they rise to the liquid surface and are they directly expelled to the vapor space, and that has the rapid evaporation. Now we will discuss about the mechanism. The mechanism and the cycle of the bubble formation has been illustrated in figure 12.9. First of all, we will discuss about liquid. Next to the heated surface becomes superheated. Next is vapor nucleus of sufficient size is created to initiate the formation of bubble. The next is bubble grows in size and the pushes the layer of the superheated liquid away from the heated surface. And the next is top of the bubble comes into contact with the cooler liquid, and that is a tendency to arrest the bubble growth. Next is inertia of the liquid, and the less cause the bubble to grow to a size and position, that is the loss of more heat to the cooler liquid, then it comes by conduction from the surface. Next is bubble begins to collapse and the cooler liquid gains velocity in the bubble bubble. The next is when the surface is a total collapse and the inertia of the cooler liquids brings in contact with the heating interface. Eventually, the cooler liquid gets heated above the separation temperature and another cycle of bubble formation and its collapse begins. The nuclear, the nucleation The nucleation's boiling is thus characterized by the motion of bubbles at the nucleation sites and the resulting liquid degradations. The bubble agitations induce a considerable mixing and promote substantial increase in the heat flux and the boiling heat of circulation. Now we will discuss about film boiling. The formation is very rapid. The bubble blanket and the rapid uh, and heating surface and prevent the incoming fresh liquid from contacting the vessels. Eventually, the bubble collapse and form of vapor film, which covers the surface completely, insulating effect of the vapor film. Its low thermal conductivity overshadows the beneficial effects of the liquid agitations and consequently the heat flux drops with growth in the temperature axis. Within the temperature ranges, delta T lies between the 50 to 150 degrees centigrade. Delta T is the temperature between uh, which is the temperature between two two systems like hot and cold. Conditions oscillate between nucleate and film boiling, and this phase is referred to as a transition boiling. Unstable film boiling or partial film boiling, eventually the temperature differences are so large that radiant heat flux becomes significant. Rather, controlling factor and the heat flux begins to rise upward with the increasing temperature axis. That marks the region of stable film boiling. The phenomenon of stable film boils is referred to as the Lanfrost effect. Now we will discuss about vaporization. Now we will discuss about vaporization. Here we will discuss about the different definitions of vaporizations, examples, types of vaporizations, and causes of vaporizations. First of all, we will discuss about vaporizations. Definition of vaporizations: the phase transitions of a substance from the liquid phase to the gaseous. There are two types of vaporizations: solid and evaporations. For this reason, for traditional evaporation is a surface phenomenon that bubble solid bulk phenomenon. Example: water boiling. Water is vaporized when it is boiled on the stove to cook some pasta, and much of it forms into a stew. Water evaporates from a puddle or a pool during a hot summer day. As for evaporation, evaporations are classified into two types: evaporations and boiling. Causes of evaporation: temperature increase causes molecules to move quickly, and this motion breaks the intermolecular bonds between the atoms. As bonds are broken, these molecules and atoms separate and spread out, which causes them to vaporize or turn into a gas. Now, we will discuss about droplet convection. In droplet condensation, the condensate liquid in the form of the countless droplets of varying diameters on, on the condensing surface. Instead of forming a continuous film and does not wet the solid cooling surface, the droplets develop at points of surface imperfections like pit, scratch, condensation site, and grow in the then commits excess is the elements in a droplet cycle from the surface into the of the droplet and spreads to the the more droplets diverse the droplets smaller in size and then more active in some of the extremely large droplets can be heat transfer and as a result heat transfer can be achieved for 10 times larger than for associated. So 3 to 4 times is more common. Portion are large, so can be heated the smaller surfaces, smaller and less expensive products achieved or sorted had only impurities or water, silicones, Teflon, assortment of and these products are work condensation, but products are unstable and their effectiveness with time due to oxidations, falling and removal of the promoter from the surface. The total amount of heat transferred to a single droplet is a function of its radius and the size distribution over the condensation surface. The important factors which are involved in the mechanism of heat transfer through a single droplets are first thermal conduction through a single droplet, second thermal conduction so, in a substrate material, third is interface matter transfer at the vapor liquid interface, and the fourth is curvature of the vapor liquid interface. Regenerative heat exchanger. In regenerative heat exchanger, we will discuss about first of all introduction, second is types of regenerator, third is advantages of regenerators, and the last is disadvantages of regenerators. First of all, we will discuss about introductions. A regenerative heat exchanger, or more commonly a regenerator, is a type of heat exchanger where heat from the hot fluid uh, is intermittently stored in a thermal storage medium before it is transferred to the cold fluid. To accomplish this, the hot fluid is brought into contact with the heat storage medium. Then the fluid is displaced with the cold fluid, which absorbs the heat. Types of regenerators. Here we discussed about two types of regenerators, like rotatory regenerators, and next is fixed matrix regenerators. Uh, First of all, rotatory regenerators. In rotatory regenerators or thermal wheels, the heat storage matrix in the form of a wheel or drum that rotates continuously through two counterflowing streams of fluid. In this way, the two streams are mostly separated. Only one stream flows through each sections of the matrix at a time. However, over the courses of a rotation, both streams eventually flow through all sections of the matrix in successions. The heat storage medium can be relatively fine, grained set of the metal plates or wire mesh. made of some resistance alloy or coated to resist chemical attack by the processed foods or made by the ceramics in high temperature applications. In a fixed metric regenerator, a single fluid stream has a cylindrical reversible flow. In single fluid stream has cylindrically reversible flow, it is said to flow countercurrent. This regenerator may be part of the valve system, such as the Stirling engine. In another configuration, the fluid is ducted through valves to different metrics in alternate operating periods, resulting in outlet temperature that vary with time. For example, a blast furnace may have several stoves or checkers full of the refractory fire brick. Advantages of regenerator. The advantages of regenerator over a recuperating counterflowing heat exchanger is that it has a much higher surface area for the removal. It has a reduced absolute volume heat, energy intensity, hardness, and pressure. The methods are regenerated are more economical in terms of materials and manufacturing compared to an important recuperate. The design of regenerator does push to distribute hot or fluids in a matrix in much the counterflow the this is that all explore different secondary regenerator will not build entire use one matrix at a time to fix a regenerator. Furthermore, flow cells for flow battery regenerators can be used to reduce pressure on the fluid. The metric process of regenerators also have itself metric characteristics using of full and frozen. Finally, properties such as small surface density and counterflow arrangement of regenerators make it ideal for gas facilities that requiring exiting 85%. The heat transfer in much lower for gas than for liquid just in a surface area in a regenerator greatly increase heat transfer. Disadvantage regenerator. The major disadvantages of it can that regenerators always some of the stream and it cannot be completely there is there is an unavoidable small stream block the regenerator that inside the in a matrix regenerator area of the volume of the matrix fraction with the therefore the regenerators are used for two fluids to be mixed. Deploy also for sealed and transportation. It best processing of fluid contamination is prohibited loss. Thank you. And now we will discuss about some multiple choice questions. Then the first question is a spring is defined as an dash machine element. Option A plastic, option B elastic, option C special purpose या option D none of the above. So correct answer is option B elastic. जब हमने जब मशीन के बारे में जब हम लोग जब डिस्कशन किया था तो उसके डेफिनेशन के अंदर हमने एक पर्टिकुलर टर्म के बारे में बात करते हैं कि अ मशीन इज द इलास्टिक एलिमेंट, और वो इलास्टिक एलिमेंट उसको क्यों कहा गया था, क्योंकि सर वो हमारी इलास्टिक की प्रॉपर्टी जो होती है उस इलास्टिक प्रॉपर्टी लाइक उस इलास्टिक की प्रॉपर्टी कैरी करती है। मीन्स कि अब जब भी कोई एक हमारी स्प्रिंग होगी, और जब उस स्प्रिंग के ऊपर जब भी एक्सटर्नल फोर्स लगाया जाता है देन वो अपनी शेप साइज से कुछ उसके ऊपर एक्सटर्नल फोर्स को रिमूव किया जाता है, वो अपनी ओरिजिनल शेप एंड साइज के अंदर वापस आ जाती है। और ये प्रॉपर्टी जो है हमारी इलास्टिक प्रॉपर्टी होती है। सो वी कॉल्ड वी आल्सो कॉल्ड कि स्प्रिंग इज द मशीनिंग स्प्रिंग इज द इलास्टिक मशीनिंग एलिमेंट which is uh, which is written in original shape and size when the remove action. So are machine. Question number 2. In which of the following item a spring is used to store energy? Option A clocks, option B toys, option C circuit breakers, या option D all of the above. So the correct answer is option D all of the above, because कि जब हम स्प्रिंग के बारे में जब हम बात करते हैं और स्प्रिंग की जब एप्लीकेशंस के बारे में जब हम लोग बात करते हैं तो उसके अंदर हम टर्म के बारे में बात करी थी, और वो पर्टिकुलर टर्म हमारी ये थी कि अ, उस पर्टिकुलर और उस स्प्रिंग एप्लीकेशंस के अंदर हमारी पर्टिकुलर टर्म ये थी कि वो हमारी किसी भी एनर्जी को स्टोर मतलब कि वो हमारे उस ऑब्जेक्ट की एनर्जी को स्टोर करके रखता है। कि मीन्स कि इस किसी भी जो पर्टिकुलर ऑब्जेक्ट को जब वो हमारे मूवेबल कंडीशन में हो और उसकी एनर्जी को अगर स्टोर करना हो तो हम उसके लिए हम स्प्रिंग को यूज में लेते हैं। और इस स्टेटमेंट को आइडेंटिफाई करने के लिए हमने सम एग्जाम्पल यूज में लिए थे। उनमें से ये 3 एग्जांपल भी हमारे आते हैं, लाइक क्लॉक्स हो गया, टॉयज हो गया एंड सर्किट ब्रेकर्स हो गए। कि इनके अंदर मीन्स कि जब हम लोग एक्सटर्नल फोर्स को रिमूव करते हैं, तो जब हम एक्सटर्नल फोर्स लगाते हैं तो वो जो एनर्जी सेविंग का काम जो करता है वो उसमें लगी स्प्रिंग करती है। फिर वो चाहे हमारी क्लॉक्स हो, चाहे हमारे टॉयज हो, हमारे खिलौने हो, या चाहे हमारा सर्किट ब्रेकर हो। सो कि इसका यूज जो है मतलब कि स्टोर एनर्जी मतलब कि इस पर्टिकुलर ऐप इस स्प्रिंग की पर्टिकुलर एप्लीकेशंस के लिए जहाँ पर वो हमारी स्टोर एनर्जी को स्टोर करके रखता है, उसका एग्जांपल हमारा क्लॉक्स भी हो सकता है, टॉयज भी हो सकता है एंड सर्किट ब्रेकर्स भी हो सकता है। सो द करेक्ट आंसर इज ऑप्शन डी ऑल ऑफ द अबव, लाइक क्लॉक्स, टॉयज एंड सर्किट ब्रेकर्स। क्वेश्चन नंबर थर्ड. In compression spring, the external tends to option A shorten the spring, option B lengthen the spring, option C both A and C, या ए एंड बी, या ऑप्शन डी इज कीप द लेंथ सेम। मीन्स कि इसके अंदर कहा गया है कि जब भी आप किसी भी एक पर्टिकुलर स्प्रिंग को जब आप कंप्रेस्ड करोगे, कंप्रेस्ड का मीन्स कि उसको दबाओगे, तो एक्सटर्नल फोर्स कहाँ मतलब कि कहाँ टेंड करेगा, मीन्स कि उस स्प्रिंग की जो है कि हमारी उस स्प्रिंग की शेप एंड साइज या उसकी प्रॉपर्टी क्या हो जाएगी। देन कि हम जानते हैं कि सर किसी भी स्प्रिंग या किसी भी ऑब्जेक्ट को जब आप लोग कंप्रेस करोगे, दबाएंगे, देन जो उस स्प्रिंग की जो लेंथ जो है या शेप एंड साइज जो है वो हमारी स्मॉल हो जाएगी, शॉर्ट हो जाएगी। सो द करेक्ट आंसर इज ऑप्शन ए, शॉर्टन द लेंथ। Question number 4. Torsional shear stress are induced in the spring wire when option A spring is under compression, option B spring the under tension, option C both A and B, या option D none of the above। मीन्स की कहा गया है कि जब किसी भी स्प्रिंग वायर में टॉर्जनल शेयर स्ट्रेस लगाया जाए तो इसके अंदर से कौन सी कंडीशन होगी, कि स्प्रिंग हमारे कंप्रेशन के अंदर वर्क करेगी, वो हमारे टेंशन के अंदर वर्क करेगी, वो हमारी दोनों के अंदर वर्क करेगी, या दोनों के अंदर ही वर्क नहीं करेगी। सो द करेक्ट आंसर इज ऑप्शन सी बोथ ए एंड बी,
बिकॉज कि जब भी हम शेयर स्ट्रेस के बारे में बात करते हैं तो शेयर स्ट्रेस के अंदर हम शेयर स्ट्रेस के साथ साथ में उसके कॉम्प्रेशन प्रॉपर्टी एंड एक्सटेंशन प्रॉपर्टी ऑब्लिक टेंशन प्रॉपर्टी के बारे में भी अपन बात करते हैं. सो द करेक्ट आंसर इज ऑप्शन सी, बोथ ए एंड बी लाइक स्प्रिंग आर वर्किंग अंडर द compressions एंड टेंशन. Question number fifth. Question number fifth. The helix angle in case of the closely coiled helical spring. Option A less than 10 degree. Option B 10 degree to 15 degree. Option C 15 degree to 20 degree. या option D more than 20 degree. So the correct answer is option A less than 20 degree. मीन्स कोई भी स्प्रिंग जो कि हमारी क्लोजली कॉइल हेलिकल स्प्रिंग होगी तब उसके अंदर जो हेलिक्स एंगल होगा उस वो कितने डिग्री पर मूव करेगा या कितने डिग्री पर वो एक्सटेंड करेगा, कितनी डिग्री पर स्टैंड करेगा. सो द करेक्ट आंसर इज ऑप्शन ए लेस देन 10 डिग्री. मीन्स कि उसका जो एक जो एंगल जो होगा वो हमारे 10 डिग्री से भी कम होगा व्हेन द स्प्रिंग आर वर्किंग एज अ क्लोजली कॉइल हेलिकल स्प्रिंग. The helix angle in case of closely coiled helical spring. Option A less than 5 degree. Option B 5 degree to 7 degree. Option C 7 degree to 10 degree. या option D is more than 10 degree. So the correct answer is option C मोर देन 10 डिग्री. मीन्स कि कोई भी जो एक हमारी क्लोजली कॉइल हेलिकल स्प्रिंग जो हमारी होगी वो उसका मतलब कि उस हेलिकल स्प्रिंग हमारी क्लोजली कॉइल्ड हेलिकल के अंदर उसका जो एंगल जो होगा वो हमारे 10 डिग्री से ज़्यादा होगा. सो द करेक्ट आंसर इज ऑप्शन डी मोर देन 10 डिग्री. क्वेश्चन नंबर 8. The longest leaf in semi-elliptical leaf spring is known as option A chief leaf, option B master leaf, option A chief leaf, option B master leaf, option C major leaf या option D higher leaf. So the correct answer is option B master leaf because it is a semi-elliptical leaf in the case of the longest leaf. Question number 7. Helical torsion spring is used in option A door hinges, option B door closures, option B automobile starters या option D all of the above. So the correct answer is option D all of the above because कि हेलिकल टॉर्जन स्प्रिंग का यूज जो है हम लोग टॉर्जन स्प्रिंग डोर हिंग्स में भी कर सकते हैं, डोर क्लोजर्स में भी इसका यूज किया जाता है और ऑटोमोबाइल स्टार्टर्स के अंदर भी हेलिकल टॉर्जन स्प्रिंग का यूज किया जाता है. सो द करेक्ट आंसर इज ऑप्शन डी ऑल ऑफ द अबव. Question number 9. The leaf of multi-leaf spring are subjected to option A bending stress, option B shear stress, option C axial stress या option D is all of the above. So the correct answer is option A bending stress because कि जो एक हमारी मल्टी लीफ स्प्रिंग की जो लीव्स जो होती है वो हमारी बेंडिंग स्ट्रेस के साथ में प्रभावित होती है, बेंडिंग स्ट्रेस के साथ में सब्जेक्टेड होती है, ये बेंडिंग स्ट्रेस के साथ में डायरेक्टली प्रोपोर्शनल होती है. व्हेन we increase the multi-leaf spring, then bending stress also increase, and then when decrease the multi-leaf spring, bending stress is also decrease. So the correct answer is option A, bending stress. Question number 10. Question number 10. Multi-leaf spring are used in Option A, automobile suspension. Option B, railroad suspension. Option C, both, and B, या option D, none of the above. So the correct answer is option C, both A and B. Because multi-leaf spring का use जो है हम लोग ऑटोमोबाइल सस्पेंशन में भी कर सकते हैं एंड रेलरोड सस्पेंशन में भी इसका यूज किया जा सकता है. So the correct answer is option C, both and B, automobile suspensions and railroad suspension are used in the multi-leaf spring. Question number 11. The, the spring index C is option A, mean coil diameter oblique wire diameter, option C, wire diameter oblique mean coil diameter, option C, wire diameter into mean coil diameter, या option D, none of the above. So the correct answer is option A, mean coil diameter divided by wire diameter. Because कि इस spring index का use जो है हम लोग मतलब कि स्प्रिंग इंडेक्स का फॉर्मूला हमारा होता है मीन कि हम जानते हैं कि सर स्प्रिंग इंडेक्स हमारी मीन किसी भी स्प्रिंग के मीन कॉइल डायमीटर और वायर डायमीटर का रेशियो होता है. देन द स्प्रिंग इंडेक्स विच इज डिनोटेड बाय सी, द फॉर्मूला इज मीन कॉइल डायमीटर कैपिटल डी अपॉन वायर डायमीटर स्मॉल डी. सो द करेक्ट आंसर इज ऑप्शन ए, मीन कॉइल डायमीटर डिवाइडेड बाय वायर डायमीटर. Question number 11. Question number 12. The spring index indicates the relative sharpness of the dash of the coil. Option A, length. Option B, curvature. Option C, thickness. या option D, none of the above. So the correct answer is option B, curvature. कि जो हमारी स्प्रिंग यहाँ पर हमसे पूछा गया है कि जो स्प्रिंग इंडेक्स हमारी कॉइल की मतलब कि शार्प मतलब कि कॉइल की किस शार्पनेस को डिफाइन करती है, तो इसका सही आंसर होगा कर्वेचर. मीन्स कि कोई भी एक स्प्रिंग को कितना अमाउंट ऑफ कर्व देना या उसके कर्व का एंगल कितना होगा या उसकी क्या वैल्यू होगी, इस चीज को जो है हम लोग स्प्रिंग इंडेक्स विच इज डिनोटेड बाय सी के थ्रू डिफाइन कर सकते हैं. सो द करेक्ट आंसर इज ऑप्शन बी, curvature, which is used for the indicates and represent the sharpness of the curvature of the coil. Question number 13. A spring index from is considered as best for the manufacturer considerations. Option A, 4 to 12. Option B, 12 to 20. Option C, 20 to 28. Yeah, option D is 28 to 36. So the correct answer is option A, 4 to 12. मीन्स कि किसी भी एक मैन्युफैक्चरिंग कंसिडरेशन के लिए अगर हम लोग ये सोचें कि स्प्रिंग इंडेक्स की वैल्यू कितनी होनी चाहिए, तो हम लोगों को पता है कि किसी भी मैन्युफैक्चरिंग कंसिडरेशन के लिए जहाँ पर हम स्प्रिंग की डिजाइनिंग करें वहाँ पर हमारे स्प्रिंग इंडेक्स की वैल्यू 4 to 12 होनी चाहिए, मीन्स 4 से 12 होनी चाहिए. सो द करेक्ट आंसर इज ऑप्शन ए, 4 to 12. Question number 14. Axial length of the spring which is so compressed that the adjacent coil touch each other. Option A, compressed length. Option B, solid length. Option C, free length. या option D, none of the above. So the correct answer is option B, solid length. कि axial length of the मतलब कि किसी भी एक spring जो उसको कंप्रेस करती है जहाँ और वहां पर जो हमारी जो एडजस्टेंट कॉइल जो होती है जो कि मतलब कि एक कॉइल दूसरे को और दूसरे कॉइल के साथ टच होती है, मीन्स कि इस की कॉइल 1 कॉइल 2 के साथ टच होगी, टू कॉइल 3 के साथ में टच होगी और कॉइल 3 4 के साथ में टच. तो ये जो एक दूसरे के साथ में जो होते हैं कनेक्ट होते हैं, तो ये कौन सी को कंसिडर कर यहाँ पर हम बताएंगे कि ये हमारे विच टाइप्स ऑफ लेंथ आर इन दिस ट्रीटमेंट. देन correct answer is option B. So, question number 15th. axial length of an unloaded helical compression spring is called option A compressed length, option B solid length, option C free length या option D none of the above. So the correct answer is option C free length. कि अगर मतलब कि कोई भी एक हमारी स्प्रिंग है जो कि हमारी एक्सियल लेंथ कंसिडर कर रही है और उसके ऊपर किसी भी तरह का कोई लोड नहीं लग रहा, वो हमारी अनलोडेड है और उसको अगर हम लोग अनलोडेड हेलिकल कॉम्प्रेशन स्प्रिंग बोल रहे हैं, देन which types of length are used in this statement? So the correct answer is option C free length. कि अगर किसी भी स्प्रिंग के ऊपर कोई भी लोड हमारा नहीं लग रहा है, मीन्स कोई एडजस्टेंट कोई एक दूसरे के साथ में टच में नहीं आ रही है, एक दूसरे के साथ में कनेक्ट नहीं हो रही है, देन वो मतलब देन उस कंडीशन के अंदर वो जो हमारी लेंथ कंसिडर की जाएगी वो हमारी फ्री लेंथ होगी. सो द करेक्ट आंसर इज ऑप्शन सी फ्री लेंथ. The force question number The force required to produce unit deflection is known as the option A gradient of spring, option B stiffness of spring, option C spring constant, या option D all of the above. So the correct answer is option D all of the above. कि मीन्स कि जो एक हमारी किसी भी स्प्रिंग के अंदर जो एक फोर्स रिक्वायर्ड है डिफ्लेक्शन को प्रोड्यूस करने के लिए, उसको हम क्या बोलेंगे सर? उसको हम ग्रेडियंट ऑफ स्प्रिंग भी बोल सकते हैं, स्टिफनेस ऑफ स्प्रिंग भी बोल सकते हैं, एंड स्प्रिंग कांस्टेंट भी बोल सकते हैं. सो द करेक्ट आंसर इज ऑप्शन डी ऑल ऑफ द अबव, बिकॉज इन दिस स्टेटमेंट which also known as gradient of spring, stiffness of the spring and spring constant. Next, the coils of the spring which are in contact with the seat and do not contribute to spring action are called option A resting coils, option B static coils, option C inactive coils, या option D ideal coils. So the correct answer is option C inactive coils. मीन्स कि जो एक हमारे coils of the spring जो होगी जब वो हमारी सीट के साथ में कनेक्ट को कंट्रीब्यूट नहीं कर रही है, types of coils are used in the coils. Question number eight. Following is are styles as of and style of having compression spring. Option A plain ends, option B plain and ends, option C square and option D all of the above. So the correct answer is option D all of the above. हम लोग उसके अंदर plain end का जो statement एंड का जो कॉन्सेप्ट है एंड ऑप्शन जो हम इसका जो कॉन्सेप्ट है उसको भी यूज में किया है. सो द करेक्ट आंसर इज ऑप्शन डी ऑल ऑफ द अबव, means plain and ground ends and ground ends which are used in the form of the helical compression spring for a end style end. Number of inactive coils in plan end is are option A 0, option B 1, option C 2 या option D 3. कि मतलब किसी भी प्लेन एंड के अंदर इनएक्टिव मतलब कितने नंबर ऑफ इनएक्टिव कॉइल्स होंगे तो वो हमारे जीरो होंगे. मीन्स कि जब भी हम प्लेन एंड के बारे में बात करते हैं तो उसके अंदर हमारी जितनी कॉइल्स होती है वो सारी एक्टिव होती है. मीन्स उसके ऊपर एक्सटर्नल फोर्स को कंसिडर किया जाता है, उसकी शेप एंड साइज इस तरीके की होती है. सो वहां पर इनएक्टिव कॉइल्स हमारी नेग्लिजिबल हो जाती है. सो द करेक्ट आंसर इज जीरो फॉर द यूज ऑफ द इनएक्टिव नंबर ऑफ इनएक्टिव कॉइल्स इन द प्लेन एंड. Question number next. The length of one coil in the spring is option A pi into D, option B 2 pi into D, option C pi d by 2 या option D pi d by 4. So the correct answer is option A pi into D, which are used for the वो वन कॉइल इन कि किसी भी स्प्रिंग में वन कॉइल की लेंथ को मेजर करने के लिए जो एक पर्टिकुलर फॉर्मूला यूज में लिया जाता है वो लिया जाता है पाई इंटू डी। क्वेश्चन नंबर नेक्स्ट, द स्ट्रेन एनर्जी विच इज डिनोट the strain energy which is denoted by E stored in the spring is where P is equal to load and delta is equal to friction of the spring. Well, the formula is P delta by 2 2 delta, option C P delta by 3, the option D is P delta by 4. So the correct answer is option A, P delta by 2, which is used in the strain energy load. For two spring in series, effective spring K is where K1 and K2 are stiffness of the spring 1 and 2 respectively. Option A K1 K2 by K1 K2 divided by K1 plus K2. Option B K1 plus K2. Option C K1 K2. Option D is K1 plus K2 divided by K1 K2. So the correct answer is option A K1 K2 divided by K1 plus K2. Next, for two spring in parallel, effective stiffness, which is denoted by K, is where K1 and K2 are stiffness of the spring, first and second respectively. Option A K1 K2 divided by K1 plus K2. Option B K1 plus K2. Option C K1 K2. Yeah, option D is K1 plus K2 divided by K1 K2. So the correct answer is option B K1 plus K2. A factor of safety in the design of a spring is usually option A 1.5 or less, option B 3 or less, option C 4.5 or less, yeah, or option D 6 or less. So the correct answer is option A 1.5 or less. A concentric spring consists of two helical compression spring is option A both spring always have right hand helix, option B both spring always have left hand helix, option C both spring always have opposite end of helix, yeah, option D is any of the above. So the correct answer is option C both spring always have opposite hand of the helix. Next question. Concentric spring are used in option A heavy duty diesel engines, option B aircraft engine, option C railroad suspension, option D none of the above. So the correct answer is option D none of the above, because concentric spring जो है वो हमारी heavy duty diesel engine के अंदर भी यूज में आती है, aircraft engine के अंदर भी इसको यूज किया जाता है और railroad suspension के अंदर भी इसका यूज किया जाता है. The initial gap between the extra full length leaf and the graduated length leaf before the assembly is called option A clearance, option B nip, option C gap, option D I. So the correct answer is option B nip. The method used to induce a layer of the residual compressive stress on the surface of the spring wire is option A short pinning, option B burnishing, option C lapping, option D none of the above. So the correct answer is option A short pinning. Thank you.